Here's a breakdown of ground fault protection of equipment on optional standby systems, addressing your specific electrical setup. Your proposed configuration, utilizing a 3-pole transfer switch in this scenario, is indeed workable. The system involves a 2000 amp service of 480 volts, Y277, 3-phase, 4-wire, feeding into a 2000 amp ground fault protection of equipment main. From that point, a 2000 amp 3-wire feeder, including an equipment ground, extends to a transfer switch and subsequently to a distribution panel serving 3-phase loads exclusively. This distribution panel's 3-wire configuration, carrying L1, L2, and L3, is grounded appropriately at the ground fault protection of equipment main. This is acceptable because the loads are inherently 3-phase and therefore bypass the need for a neutral connection at the distribution panel itself. On the generator side, you have a 1500 kV amps, 480 volts, Y277 3-phase 4-wire generator located 300 feet outside the building. This generator is equipped with its own 2000 amp ground fault protection of equipment breaker. The connection to the building is established using a 3-wire configuration, once again including an equipment ground, running to a disconnect and subsequently to the transfer switch. The key to this setup's functionality lies in the application of a 3-pole transfer switch. A 3-pole switch manages the 3-phase lines L1, L2, and L3, switching between the normal utility source and the emergency generator source. The neutral from the generator is not switched in this configuration, and it's not needed for the 3-phase loads served by the distribution panel. The UPS or uninterruptible power supply systems connected to this distribution panel are specified to operate without a neutral connection. Consequently, these UPS units are not expected to experience nuisance tripping during transfer switch operations, as they are designed to function solely on the 3-phase power provided. However, there are important considerations. 1. Ensuring the transfer switch has an adequate current and voltage rating for your specific system is essential for safe and effective operation. 2. A properly engineered and installed grounding system is critical. This minimizes the risk of ground faults and ensures personnel safety. 3. Consistent testing and maintenance of both the transfer switch and the generator are vital for sustained reliability, particularly during power outages. This includes regular inspections, simulations of power loss scenarios, and verification of proper transfer switch operation.